person will be today. Our resource person will be Dr. Harmanpreet Singh Kapoor. Before inviting him, I would like to introduce. He is an esteemed assistant professor in the Department of Mathematics and Statistics at the School of Basic Sciences. Holds a PhD in statistics from Punjab University, Chandigarh. Earned in 2014, along with a gold medal in MSc Statistics in 2009. With an extensive professional background, he has successfully completed actuarial examination from the Institute of Actuaries of India, specializing in various areas including financial mathematics and statistical methods. In his 11 years of research experience, Dr. Kapoor has become an expert in actuarial statistics, statistical modeling, inferential statistics, and biostatistics, currently serving as an assistant professor at the Central University of Punjab since August 2015. He previously held a position at Baba Farid College, Bathinda. Dr. Kapoor's notable contribution in actuarial sciences showcased through published papers and recognized achievements such as a gold medal in MSc Statistics, affirm his prowess. Engaging in research collaborations, he has secured prestigious research grants, including a DST SERB Funds project on groundwater depletion. An active member of professional organizations, Dr. Kapoor's commitment to educational is evident through his participation in national and international conferences, workshops, and seminars. He has organized significant academic events and is a resource person, delivered expert lectures and workshops on diverse topics. In summary, Dr. Manpreet Singh Kapoor stands an a dedicated academician is and researchers making substantial contribution to the mathematics, statistics, and actuarial sciences. So once again, welcome to all the participants in this session, and welcome, dear professor, for your valuable time. And now over to
Thank you,
you.
sir. Thank you, sir. Thank you. So good afternoon to all of you. So first, I would like to thank Dr. Meherchand and the organizing team for giving me this opportunity to share my knowledge with you. So I'm audible, right?
Yes, sir, you are audible.
Okay.
Perfect audible.
Okay, thank you. So let me start today's session. So before going to start today's session, so I have discussed with Dr. Meher that we have audience from social science background, right? So basically, my main objective is that whatever thing we are going to discuss, so you should be able to understand that thing. Okay, so for that, I'm going to very much slow. That means I'm going to ask to the audience in between whether they are able to understand the logic or point, but whatever I'm going to discuss with you. So I need participation from the audience. So I think I request all the participants that wherever they found any, wherever they will think that there is some issue that they are not able to understand, they can interrupt me in between and we have a discussion session in between, right? So today I'm going to discuss about that why we this topic that is called linear correlation and simple linear regression, why this topic is very important for social sciences. So before going to start today's session, my screen is visible to all of you, right?
Yes, sir.
Okay,
Visible.
fine.
Yes, sir.
Okay, fine. Thank you. So I want to know about that. How many of you are very much confident about the term statistics? What do you think what statistics is? If you participate, then only I can understand that whether you have a very strong understanding about the topic, or otherwise I'm going to help you to understand it better, man. Any Any person can respond. So what do you think, what statistics is, why statistics important for your research, for your daily life activities, anything, any guesses? Okay, so if so basically I'm not getting any response. Let me see. Okay, statistics is a discipline that concerns the collection, organization, reputation. Okay, so the thing the person has written, that is very good enough. That means whatever the thing that person has written, that is good. But in simple term, if someone has to explain to a layman person that how one can use statistics in real life, then what we can say?
I think statistics is the collection of data, like in a situation where a country will say we're doing stats of the population. So it's a
Okay.
collection of data and analysis of the data.
So
Thank you.
basically in statistics that provides you tool how to collect the data. So it's not just statistics is a data collection of data. So basically we talk about that whatever the data set you have with you, using the tools that we will discuss in statistics, that helps to extract the information from the data set. My point is clear? Hello? My point is clear to you, right? Or not? Tell me. So basically, when we talk about statistics, so in statistics, we talk about tools, methods, techniques that helps to collect the data. That means how you're going to collect the data. If you're doing any primary survey or secondary survey, that means primary survey, and whatever if you have a data set with you, how to analyze those data set. Hope all of you agree with me. Okay, so I'm not going to spend more time on that. Let me tell you. So statistics, I already discussed with you. Statistics is a science that helps you to for the collection of the data set. That means it helps you, it explains that what are tools available in the literature or methods available that helps you to collect the data set. Okay, and if you're able to collect the data set, then how you can analyze it further, so that after analysis you are able to get some results, right? And those results are helpful for your objective or research purpose. So basically we segregate statistics in two major branches. One is called descriptive and second one is called inferential. So I think most of you have heard about term descriptive. So what do you think what descriptive is? Anyone? The reason is because why I'm discussing these things, that because somehow it may possible that maybe some it means most of the participants are not from math background, right? And even stats background. So we have interaction session first, and when I will start discussing the topic, then only you can understand it better manner. Because if you are not able to understand the basic things, basic differences, then whatever tools I'm going to discuss, so you may not be able to understand it properly. Okay, so basically in descriptive statistics, so let us suppose if someone wants to conduct a survey, that means someone wants to do some collect information in terms of primary source. So one has to prepare some questionnaire, right? So the questionnaire consists of questions from the person name. It starts with the person details, it age, income, and sex or gender. Okay, and after that, if you're doing any quantitative survey, I will tell you what is the meaning of quantitative and qualitative. If you're doing response. It means in your questionnaire you have your questions corresponding to uh, quantity information of the respondent. Then you can keep rest of the questions according to that, right? So this information that we have collected, right? We want to analyze it further. Agree with me or not? I'm audible, right?
Yes.
Okay. So now the thing is that if we have only that means we have collected the information from 100 respondents, and we assume that this 100 respondent is my whole population. That means these 100 respondent covers my objective. Okay, there is no any person that that is out of this survey. So I have collected all the information from the 100 respondent. Now the next task is that I have to summarize this information. That means I have to see that how much persons we have in our survey that we have done. Most of the person belongs to which category of age, which type of persons we have in our survey. Most of them, whether they are young, whether they are old, whether they are minor. Okay, so how you will do that? I'm not getting any response from the audience. So basically, if you want very interactive session, then you will enjoy it better. Otherwise, I will start teaching in one way communication. It's only. Okay, fine. So basically, what I want to discuss in today's
Your
session
voice
is.
is breaking.
Sorry.
Sir, your voice is breaking between.
My voice is breaking.
Yeah.
Dr. Meher, whether this problem is coming, can you confirm?
Now we can hear you. You can continue.
Okay. Basically, what I want to discuss in today's session is, so you have collected responses from 100 respondents, and in that questionnaire you have first four questions are of this format. You ask the name of the person first, then age, income, sex, and rest of them there are further list of the questions. I'm not going to discuss them because it can be quantitative, it can be qualitative. I will discuss the term what is quantitative and what is qualitative later on. But I just have a simple question for you, that we have collected responses from different persons, right? So you want to know that most of the persons belongs to which type of category of age. Then how you will do that? I want to know that. Whether most of the persons are of old age, whether most of the persons are young age, whether they are you can say middle-aged person. So how you will identify that thing?
So we will categorize the respondents on the age group.
Okay, so basically I have in my questionnaire, I have only written age. So if I have already construct a interval that 0 to 20, 20 to 40, then 40 to 60. Okay, then 60, greater than 60 onwards. Then you will check if any respondent lie in this category, right?
Yes, sir.
Okay, and after that, what you will do is you will note down that how many observations we have that belongs to this category, this category, this category, this category. And whatever if any of this category has highest number of observations among these 100. So for example, we have 30 observations that belongs to the age category 0 to 20. Then we have 40 observations that belongs to the age category 20 40. Then we have 20 persons, right? And then we have 10%. So we can say that most of the respondents are of young age because most of them lie in the age category of 20 to 40, right?
Yes, sir.
Okay.
Yes, sir.
Okay. So what we are discussing in today's session is So first, I am going to discuss with you that what is the difference between descriptive and inferential statistics. So first, I have just give you enough idea that we have some information, we have some data with us, and our main objective is how we can summarize this information so that one can understand it in easy manner. For example, so if the information is given to you in terms of continuous manner, that someone has given you information in only terms of that my age is 21. Someone has given, second one has given that information that my age is 32 and so on. Okay, so later on you can also construct these intervals on your behalf, because we are very much confident that this age group, they belongs to you can say in this age group most of the persons are doing their education only. That means they are either students, they are college going students, right? And in most of this age group, most of the person, they are doing their jobs. Okay, and here also they are doing their job, but they are not young enough. So based upon that, you can categorize them. So in descriptive statistics, what we do, whatever the information we have, we try to summarize those information using different statistical tools. My point is clear to all of you. So we have a data set with us. So whatever the variables we have, whatever the information we have, how to represent the information that is hidden in those data set, that is whatever the information we have, how we can present that information that is hidden in the data in more understandable manner. For that, we go with the descriptive statistics. Okay, so now the second part is called inferential statistics. So what do you mean by inferential statistics? If someone has any idea?
So where we
So
try to infer something from that data, or basically we want to go on some conclusion from that data.
yeah. So basically, in inferential statistics, maybe if someone is not a someone has heard this term first time, let me tell you. So now in the descriptive statistics, I have taken the example that I have 100 respondent only, and all those respondent covered my objective. That means whatever the research question I have with me, and I have collected the information from these 100 respondent, and there is no other respondent outside this you can say group of 100 persons that to whom I have to collect the information. For example, so I have collected this information from a village or any town. Okay, and I can say that the observations that belongs to this village or town, that covered my whole objective study. Okay, so now if I want to conduct a survey on the behalf, that means I have objective that I want to conduct a survey at state level, but I know that do not have any so much resources with me that I can do study at the level of state. What I do is I consider some of the districts. Okay, I choose some of the districts, and then among these districts, I choose some of the villages or towns. So what I do is I collect some responses from these villages further and try to conclude. That means whatever the sample I have taken from these districts, I want to generalize the whole result for district first. Then from these district, I want to generalize the whole result for state. For that, we go with the inferential statistics. The idea is clear to you?
Yes, sir.
Okay. Okay. So now should we proceed further? If there is any doubt till this stage, you can ask me. Okay. In the most of time descriptive statistics, whatever the information we have, whatever the data set you have, you want to summarize, you want to implement statistical tools to get information from those data set only. Right? In inferential statistics, what we do, we have a small observations, we have a sample with us that is coming from the population. And the population is, that means those individuals or object that has some particular type of objective that lies in a particular type of research objective. That is my population. So here population doesn't mean that I'm talking about only counting of human being. I'm talking about that any living or non-living thing, okay, that comes under the category of my research objective, that is my population. And I'm not able to uh, I am not able to collect information from the entire number of individuals or non-living things in the that population. So what I do is I take a sample from that. Okay, and based upon the sample, whatever the conclusion I derive, I'm going to generalize that conclusion for the whole population. So that is called inferential statistics. Okay, so most of you are very much confident about that. What is data? Yes or no? All of you know what is data?
Sir, वो form of information.
Okay, group of information you can say. So data is a plural or singular term?
Plural, sir.
Okay, yeah, good. So datum is a singular term. That means datum represent single value. When we have more observation, that is called data. So data is categorized into two segments. One is called categorical or numerical data, and most of the books they also called as qualitative and quantitative. So anyone can tell me what do you mean by qualitative and quantitative?
Which we can understand in the form of numbers is called as quantitative, and
Okay.
the terms represented in some quality like beauty and something like that, that is qualitative.
Yeah, so very much close. So let me you can say extend this definition of qualitative. So basically we know that for the analysis purpose we can't do the analysis for the alphabet number. That means if we want to do any analysis, we have to assign some numbers to the categories. For example, in my questionnaire that I have taken in my previous slide, so I have one variable that is called gender, right? So that means the possible outcomes are male, female, or third gender, a third category, right? Male, female, and third gender or transgender, whatever. So now for the analysis purpose, no any programming language or any other software, they do not understand that what is male, what is female, and the third category. Okay, they can only understand the terms if we assign them numbers to them. Okay, either it can be 0, 1, 2, it can be 1, 2, 3, or it can be reverse order also. So qualitative means where we cannot quantify, okay, where we cannot quantify the categories, where we can't quantify the values of a variable. That is called qualitative data. The idea is clear? Okay, so now for the analysis purpose, we have to assign numbers to them, and these numbers are just for representation purpose. Okay, it doesn't mean that female is twice of male, third gender is thrice of male. It doesn't, it is just used for the representation purpose. Okay, so under this qualitative data set, we have further two categories. One is called nominal and second one is called ordinal. Okay, nominal means, so now in this example you can see that, so we can't say that male is better than female, female is better than third gender is better than female, and female is better than male. So all of them have their equal identity, equal weightage. So that's why it is called nominal. For example, when we talk about any religion, or you can say colors. So religion can be the person belongs to Hindu, Sikh, Christianity, Muslim, right? And colors can be red, blue, green, black. So we can't say red is better than blue, blue is better than green, green is better than black. So all these are categories and all of them have their equal identity. So that's why we assign equal weights to them. But these numbers, 1, 2, 3, or whatever the numbers we assign to them, they are just for the representation purpose. The idea is clear?
Yes, sir.
Okay. Is there any doubt till now? So if you think that I'm going very slow, then I will speed up the things, but I'm going very slow for your convenience so that you can understand it better, man. Okay. So now, so there are some variables whose categories can be aligned. That means arranged in increasing or decreasing order. So those are called ordinal. So someone can give you any idea that under which any example in which the variables categories can be assigned in increasing or decreasing order.
Sir, can you please repeat the question?
My question was, can you name any variable in which there are categories that can be assigned in increasing or decreasing order?
Sir,
Profession
any
or
race or
statutes?
something?
Which one?
Sir, when you are running in a race,
Mm-hmm.
then we can assign in 1, 2, or 3 rank.
Yes, yes. So this is a good example. There is one more example that I want to add here is, so can you say that designation is one of the most important thing? Designation, this is one possibility.
Yes, sir.
Okay. Second is, you can say that severity of disease. For example, a person may be affected with the disease of stage mild, moderate, or severe. Okay.
Yes, sir, it can be.
So I'm taking example based upon that most of the times we have categories given to us in terms of alphabetic orders, right? In alphabets, like designation can be the person is a student based upon the knowledge level or based upon the qualification level, we can arrange it. The person is PG student, then we have PhD scholar, then we have assistant professor, then associate professor, then professor, right? So we can align them according to the knowledge level or your degree level, we can say, or experience level. So in this way, when we have such a variable in which categories are there, that can be orders also. So that is called ordinal. They have the characteristics of nominal. It means we can assign numbers to them. But here, while assigning numbers to them, we also have to say that if one number is assigned to this person, two is assigned to this. So either we assign them increasing order, decreasing order. Okay. So here, category as well as assignment of number, that has some relevance also. And in this case, in the previous case of nominal, either we assign female to 1, male to 2, and third gender as 3. That doesn't matter because all of them are given equal weightage. Okay. So now coming to quantitative data set. So what do you mean by quantitative data set?
So the numerical data set which we have collected, basically,
Okay. So
that can
only
be
numerical data
quantified.
set, or there is any other example that you have in your mind?
Sir, any such type of information that financials of the companies, banking, financial performance, anything
Okay.
that can be.
Okay. Now you have given me example of any banking sector, right? You have given me that any data related to banking sector that comes under this quantitative. So basically, so you know that quantitative means that variable information that can be quantified, that can be measured using some tools. So we can measure the height with some
Yes,
tools. We can measure the weight of the person through some tools like scaling, right? We can
yes,
measure
sir.
the interest rate
Yes, sir.
Okay. So whenever the information is given to you, that can be quantified through some resources. That comes on the quantitative data set. And there are further two categories. One is continuous and second one is discrete.
Yes, sir.
So I think all of you know that integer values, that is 1, 2, 3, if that is coming and that is the outcome of some quantitative responses, that is a discrete value, because there is no any value that consists of decimal value. Okay. So when we have continuous value, for example, if you're measuring weight of a person, so it can be 78 kg, 200 grams. Okay. But if you are measuring the age of the person in discrete manner, the person must say that my age is 25, my age is 24, and so on. If we are measuring in terms of discrete order, discrete manner. Okay, we are not considering how much months and days the person has, you can say, exact. We are not talking about the exact age, we are just talking about the integer age the person has achieved till now. Okay, that is a discrete value. So that comes in a discrete category. So if we are talking about any value that consists of decimal observations also, for example, height, weight of a person, okay, that comes under continuous. So idea is clear to all of you, I think. Okay, for a convenience, I am reading these lines. Numerical variables, number that is sensible to addition and averages. Okay. Because when we are observing the weight of a person, so if one person weight is 20 and another person weight is 40, I can say that this person B, this person weight is more twice than the weight of the person A, right? It can be said, right? But when we are talking about qualitative data set, okay, so do not confuse about these two terms. When I'm talking qualitative, it means when we assign numbers to any category, gender, male and female, 1 and 2. I can't say female are or twice than male, because here the numbers are just for representation purpose. Okay, but when we're talking about weight, that means I am taking a variable weight and I am considering that the person A has weight 20, B has weight 40. I can say that the person B is double weighted than the person weight A. Right? So in that case, we have age, blood pressure. We can also think about that if the person has blood pressure of 200 or 160. Okay, and another person has blood pressure values 80. I can say that the person B blood pressure level is half than the person A blood pressure level. Okay, and I am considering both example here as a discrete value because I am not considering the decimal values here. So that's why it is called discrete data set. Okay, so now coming to the categorical variable, it has levels or classes. In nature cannot be added or averaged because we are just assigning numbers to the levels. That's why we can't add them or average them. For example, gender, I have already discussed with you. Blood group. The blood group can be A positive, B positive, O negative, O positive. So these are the numbers. These are the alphabet symbols. But for the analysis purpose, we have to assign numbers to them. If you want to note down the frequency, that how many persons belongs to blood group A, how many persons belongs to blood group B, then O positive, O negative, and so on. Right? Okay. So I have already explained that what is continuous data set, in which we measured the values using some tools, right? And we can also take the difference between two values. For example, if one person height is in terms of centimeter, we can say 150. Another person height is 120. I can say that the person A height is 30 centimeter more than person B height. I can take difference also. Okay, that is only possible in terms of quantitative data set. Okay, is it clear? Okay, and in the discrete data, there is only major difference is that we have only integer values. For example, number of deaths that can be only be represented in terms of discrete integer like 15, 20. It is not 15.5. That is a wrong thing because we can't say that 15.5% has died. We can only say that 15%, either 16%, 20% has died, right? So further, we have categorical data, as already explained to you. In the categorical, we have two further categories. One is nominal, in which we talk about levels of categories. For example, we have most commonly used example is yes or no. In your questionnaire, you put either yes or no. So either you can assign 0 to yes, 1 to no, or 1 to yes and 0 to no. Okay. So here we just assigning numbers for the representation purpose. And we use these numbers for the analysis because computer can only understand the numbers for the statistical analysis. They do not know what is yes, what is no. They only focus upon what value that we have assigned. They have to just count them to observe the frequency. How many yes has appeared in a questionnaire? How many no has appeared in a questionnaire? Okay. So in the ordinal data, the order do matter, as already discussed with the education level, rank order scales, cancer rank, or you can severity of a disease. One person is very you can say highly adversely affected with a particular type of disease. Then we can say that the person is affected, the severity is very high. Okay, the second is moderate. The third is mild. Okay. So these are order. So now today what I'm going to discuss is, so we have two variables. That means, and I am using this notation X and Y. So you can take any notation, like I'm assuming that X can be height or Y can be weight. Okay. If you are doing any research in different subject area, you can assume these X and Y corresponding to your research area. Okay. That is more convenient for your understanding. So now the one thing you have to keep in mind, that we are talking about quantitative variables. So whatever the things we are going to discuss from now onwards, our main objective is we have this requirement that they must be quantitative. Although we have some techniques available in the literature, for that we can also, that means for qualitative data set, that we can also do this regression and other things, but I'm not going to touch them for the time being. Otherwise you are going to confused. Okay, so main objective is we are observing that these X and Y variables, they coming from quantitative data set. Okay, and these notations I'm just using for your representation purpose. You can use any other notation. That means X can be any variable corresponding to your study, Y can be any other variable. So our main objective is, our first objective, if we have these two variables and we have a very simple thought in your mind whether there is any relationship between these two variables. So in statistics, we first observe the linear relationship. So can you tell me that what do you mean by linear term? Any idea from the audience? What do you mean by linear?
Linear
Okay.
is when you can approximate the relationship with a straight line.
Yeah. So I think all of you have seen such type of curve in your graduation, in your 10th or plus 2 level class. So we just observe that a straight line is called a linear. Draw a line corresponding to 45-degree angle.
Yes, sir.
Okay. So what we are trying to say here is that we start observing a relationship between two variables in a linear pattern. That means if one increase, the other must increase, one decrease, other must decrease. So our first objective is that we have to see that whether there is any relationship exists between, linear relationship exists between these two variables. Okay. And after plotting these variables X and Y here, I will show you that how one can plot it. And the plot is called scatter plot. We will discuss about it. Do not worry. But for the time being, you can assume that or some assumption is in mind that you have that these two variables are related to each other. Now, how to identify that how much relationship exists between them? For that, we go with this Pearson R, or you can speak Pearson correlation coefficient, and that shows you that the relationship between X and Y, whether that relationship is strong enough in positive manner or negative manner, or there is a mild relationship exists between these two variables. Okay, so the first objective is that we have two variables and we want to see that whether these two variables are related to each other. From the graphical representation, we get some idea that these two variables are related, right? And how much relationship they have. For that, we go with the Pearson R, that means Pearson correlation coefficient, and we get some value that lies between -1 to 1. Okay, if the value is close to 1, then we can say that the relationship exists between these two variables that is very strong. Okay, if the value is -1, we can say that the relationship exists between these two variables are strong but in negative manner. That means if one increase, other will decrease. If on the right hand side the relationship is strong on positive direction, on the negative side, on the left hand side, the relationship is also strong but on the negative side. That means if one increase, other will decrease, and here if one increase, other should also increase. Okay, and after that we will discuss that now we have observed that the relationship exists. So we will explore further whether there is any one variable, that means whether X may be helpful to determine the value of Y if the relationship is significant or strong enough, or Y can determine the value of X. So we will explore this possibility further, and we will explore this possibility using this regression equation. Are you able to visualize what we are going to cover today? First, we will consider two variables, X and Y. Okay, and we have this assumption in our mind that these observations are coming from quantitative data set, and further we will explore the relationship using graphical manner, and from the graphical manner we will see that whether we can say whether this relationship exists or not, and if the relationship exists, how much type of relationship they have, whether they have very strong relationship, whether they have a positive or negative relationship, or whether they have very mild relationship. Okay, if the relationship is strong, then we will try to model, we will try to write down a mathematical equation between these two variables using regression equation. Okay, and after that, whatever the coefficient that we are going to use in this mathematical model, we will check whether that coefficients are significant or not. Significance means whether actually that coefficient that we will construct between these two variables, whether they are actually playing a role, whether they are non-zero. Okay, so we will discuss about that. So if this idea is clear to you, then you are able to understand the whole objective of the study. Is it clear? Hello?
Clear.
Yes,
Sir.
Okay, fine. So now the relationship between X and Y. So now, as already discussed with you, correlation is the first method to observe the linear relationship between two variables. And after that, we will do the regression. Okay. In the regression, we consider any variable X or Y based upon the knowledge of the research area. Either we consider X as a dependent variable or Y as a dependent variable. And one thing you have to keep in mind that if there is a relationship exists between these two variables, it doesn't mean that leads to causation. The meaning of causation is that if there are two variables, they are related to each other, X and Y, they are related to each other. We can't say that there must be one dependent variable or one independent variable. Okay, so correlation does not lead to causation. Okay, it may be chances that sometime we got a very good variable combination in which one can be dependent, one can be independent, but it is not always the case. Okay, so this is the main thing that I want to discuss in this. Now coming to the scatter plot. Scattered gram or scatter plot, there are various names. So now you can see here is, so this is your x-axis. I think all of you have done this concept in your 10th or plus 2 level. So this is your x-axis, and you can see that we have x values are shown on the x-axis and y values are shown on the y-axis. Okay, so what are these points? Any idea? So for example, so I have x and y variable. Okay, and some we are taking continuous values, so some of the values of x can be negative. Okay, some are positive. Okay, so if someone has to plot this value minus 15 to 10, I'm taking one example for your convenience. We know that x positive reason lie on this side. That means starting from 0 to x, okay, we have positive values. From here, we have negative values of x. Okay, so we know this is 50 minus 15. So minus 15, if I'm going to plot it, it should come something here. Okay, and corresponding to that, we have value of y as 10, and y has positive reason on upper side and negative reason on the, that means y take positive value on this axis on the upper side and the negative values on the lower side. Okay, so the values of y starts from 0, 1, 2 up to 10. Okay, so I have to point, that means I have to draw this point on this x and y axis. So corresponding minus 15 to 10, the point must lie here, right? And similarly, minus 12 to 9, it should be here something. Okay, so if you draw all the points on this x and y axis, either you will get such type of such type or such type. Okay, so here you can see that because the direction of this, that means all those points, they are of So can you hear me? Sorry for technical reason. I did not notice that I was signed out. Okay. Can you hear me?
Can hear you now, sir.
Okay. I request Dr. Meher to give me access of host so that I can share my screen. Dr. Meher,
Yes, sir.
so can you give me access? Can you give me the access of host?
Mr. Pran, please co-host Dr. Kapoor. Pran, please assign co-host to Kapoor.
Yeah, thank you.
Okay, sir.
Okay, thank you. So I was so can you tell me where I left, because I don't know how much time that internet is. So are you able to understand this point, what I was discussing?
Yes, sir.
Understood.
Okay, fine, thank you. So I have just discussed with you that when this slope is of upward shape, then we can say that is positive correlation. Then when it is of downwards side, then we can say it is a negative correlation. And when all the points are scattered on the x-axis or y-axis, we can say that there is no correlation. Okay. So now the thing is that I'm going to discuss with you these two terms that are very important. One is called variance and covariance. Do not consider the mathematical formula. Just try to understand what they're trying to say. So when we talk about variance, what do you think? What is variance? And how many of you have heard this term before? Variance.
The degree of value of a variable, maybe
Okay.
how
Okay.
much a variable vary from its origin.
Okay. So let me help you to understand it better. So before going to discuss the term variance, I have to also discuss the term that is called mean. So the very simple example is, I think someone is operating microwave. Can you mute yourself? Either someone is using car or microwave. Can you mute yourself? Muhammad Sajid. Okay. So basically, the term mean is very easy. That means, for example, you have some money with you. That means you have 10,000 rupees in your hand, right? And you have this money you need for a survival for the next 1 month. Okay, we know that on daily basis, one is not able to spend equal amount of money. Sometimes you spend $10 or 10 rupees, whatever the currency in which you are dealing with. So the expenditure is different is different for all the days, right? But you have only $10,000 or 10,000 rupees in your hand. So when you are able to find out, you want to find out that how much money you have spent on daily basis. What you do is you count the total expenditure. That means whatever the expenditure you have done on daily basis, you count them and you divide them by 30, because if the month consists of 30 days, then you will divide by 30, otherwise you divide by 31 or 28, depend upon the month. So this value, that means this mean is just total of all the expenditure that you have done, that is 10,000, because I have just taken one example that you have only 10,000 rupees or dollar and you have spent all the money, and you are dividing by 30 because you have 30 days, 31 days, or 28 days. So whatever the value you will get, that shows that on average basis, what is your daily expenditure. The example is clear? Okay. So now we know that on each day, your expenditure is different. Okay. Maybe you have spent $500. Maybe you have spent 500 rupees. Sometime you have spent 200 rupees or $200. Someday you have spent $300. So you want to observe that how much variation, how much difference this daily expenditure has from its mean value. Okay, it is coming as something like 333, something like. So you want to observe that whether there is a significant difference of expenditure on daily basis from its mean value. So this term variance will help you to understand that difference. So we can say that if your expenditure varies a lot, that means the chances that your expenditure is different from 333 is very high, because if your expenditure varies a lot from 333, but if the variance is very small, so we can say that you are spending uh, rupees or dollar approximately close to 333 on daily basis. Okay, so variance will help you to understand that how much variation you have in your data set in corresponding to your mean value. Okay, so here you can say that xi is a notation that we are using that shows the expenditure of daily basis, and x bar is a notation that is used to represent the average expenditure. Okay, that is mean value, and we are taking the deviation and taking the square and dividing by total number of observations minus 1, because it is a mathematical formula. So I'm not going to discuss why we are taking n minus 1, why we're not taking n. So this formula will help you to find out the variability. Variability means how much variation you have from its mean value. If the variation is high, that means each observation is different from its mean value. If the variation is less, then most of the observations lie close to their mean value. And why this thing is important? The main question is why this thing is important, because when we have higher variability, then it is very difficult to forecast, to you can say fit a model exactly on the data set. If the variability is small, then it will be easy, because one can easily predict, one can easily forecast that how much variability we have. Now coming to the second term, that is called covariance. So here in the case of variance, I have considered one variable x, right? I am taking the variation of its x variable from its mean value and putting the values in this formula, then I will get some value of variance. But now the second thing is covariance. So covariance will be helpful to observe how much relationship a variable has with y variable, also considering the deviation of each variable from its mean value. So what we are doing here, we are taking difference of each observation x from its mean value and also the variation of y variable from its mean value, and we product them together. Okay, and why we are doing this? Because this product will help to understand that if there is no relationship exists between these two variables x and y, then the value of covariance should be close to 0. Or sometimes it happens that the answer is coming as 0 also. But that doesn't mean that in some other cases, when we have covariance value exactly 0, then we are not 100% sure that they are uncorrelated. Okay, so because there are some conditions over that. Okay, I'm not going to emphasize why covariance of xy is equal to 0, why we are not saying that they are not correlated. Okay, they are not linearly correlated, we will discuss it. But when they are non-zero, then we are 100% sure that there is some relationship exists between x and y. Okay, so now again what's the meaning of the values that we got from the covariance. So as already discussed with you, that covariance will help you to understand that how these variables x and y are related to each other. So if we increase the value of x and increase the value of y, and answer of covariance is coming as positive, then we can say that if x increases, y also increases, because from the covariance value we got a positive answer. Okay, and if the covariance is negative, then it means that either x decrease, then y increase, or x increase, y decrease. Opposite relationship between x and y. Okay, so for example, if we going back to this graph, we can see that if x increase, y also increase. Okay, but here opposite relationship exists. If x increase, y decrease, and if y increase, x decrease. Okay, and here because there is no relationship exists, we can say no correlation exists between x and y, because all the points are scattered over the whole graph. We can't say that there is a very strong relationship exists between x and y. Okay, so from the covariance we can see that if x increase, y increase, we get a positive value of covariance. If x decrease, y increase, we get a negative value of covariance. And when we have zero value of covariance, it means that no constant relationship exists. Why we have written no constant relationship? Because whatever thing we have observed till now, we have observed only linear relationship. Okay, linear means that whether increment of x and y, they are increasing in positive direction, or whether they are in negative direction, or there is some mild relationship exists. But sometimes it happens in the literature that relationship between x and y, they are non-linear. In that case, this covariance of x and y, that is zero, means they are not linear, but there may be possibility that they are non-linear relationship exists between x and y. Okay, I think the idea is clear. Covariance of x and y is equal to 0. It means that no linear relationship exists between x and y, but it is also possible that non-linear relationship also exists between them. And this covariance only observe the linear relationship between x and y. So I have considered one example for a convenience. For example, we have x variables. Okay, so here we have taken x variable as 0, 2, 3, 4, 6. Okay, y variables as 3, 2, 4, 0, 6, and so on. So we first derive the deviation from its mean value. We first derive the mean by adding them and dividing by the total number of observations we have. And similarly, we have derived the value for y bar by adding them and divide by total number of observations. So we are getting the answer 3 and 3. And we are subtracting this 3 from each observation of x and y. Okay, and then we derive total value of this product as 7. And because we are using this formula, and we got the answer as 1.75. As already discussed with you, that if the answer of covariance is coming as positive 1.75, so we can say that increment in x leads to increment in y. Okay, so you can also see this thing from the graphical representation, that although the observations are very less, okay, but still we can say that if x increases, y also increased. Okay, so this thing covers till now that we, from the graphical representation and using this formula covariance, we got some idea that there is some relationship exists between these two variables, linear relationship. Okay, and to find out whether this relationship is strong and how much strong they are, for that we go with the Pearson correlation coefficient. And the mathematical form to derive the Pearson correlation coefficient will consist of the covariance term in the numerator part that I just discussed with you, the definition of covariance, the above one, this one, and we consider these two terms, that is square root of variance of x. So this is the definition for variance of x. And if you replace this x with y, then we can say this expression will be called variance corresponding to variable y. Okay, so it means that we consider the covariance in the numerator part divided by square root of variance of x and variance of y. Okay, as already discussed earlier, that correlation coefficient values lies between -1 to 1. Okay, so if r is coming close to +1, r is coming close to +1, the relationship is positive. Linear relationship exists between these two variables, and it is strong enough. If r is coming to strictly +1, then we can say that x and y are strongly linearly related, right? Or if r is equal to -1, then x and y are strongly negative related. And if the value of r lies between -1 to 1, so any value in between helps you to understand that if it is r is equal to 0, then we can say that there is no or weak, you can say, linear relationship exists between x and y. But if the value is strictly lies between -1 to 0 or 0 to 1, then we can say that there is a mild negative relationship exists between variables x and y. And if it is lies between 0 to 1, then we can say that there exists mild positive relationship exists between x and y. Okay, the idea is clear. So there are some scatter plots that shows the above point. So here you can see that r is equal to -1. So as already discussed with you, that shows an active relationship. So why we are saying that is strongly negative relationship? Because you can observe that all these points lie on the line. Okay, although we will discuss that how one can construct this line, but for the time being you can see that all these points, they lie on a straight line. Okay, and because this is r is equal to -1, when we consider the value of r lies between -1 to 0, that means any value that is not equal to 0, not equal to -1. So we are considering r is equal to -0.6. So here you can see that although the slope is on the negative side, that means we have downward slope, but there are few points that are not on the line. They are close to the line, but not on the line. Okay. Similarly, when we have r is equal to 0, you can say that there is no you can say downward slope or upward sloping line here. We have only straight line, and most of the points are not on the line. Okay, so that shows the weak relationship or no linear relationship exists between x and y. In the same manner, when we have value r is equal to +1, you can say that we have upward slope line, right? And most of the points lie on the line. And when we have value of r that is greater than 0 but less than 1, so we have 0.3. Okay, that shows that although there are few points are on the line, but they are on the positive side. So upward sloping curve. Okay, hope the idea is clear to all of you. Hello.
Clear.
Yeah.
Clear.
Okay, fine. So now coming to linear correlation. So as already discussed with you, why it is called linear? Because we are talking about a straight line. Okay, so it can be upward sloping, it can be downward sloping, but there are some other curves that also shows the relationship between x and y, but they are not linear. They are called non-linear. And in our study, in our today's session, we are only focusing on linear correlation, simple linear regression. Okay, so curvilinear relationship exists, but means that when the relationship between x and y that exists, but they are not covered through a straight line. So either you have some different form of the equation that cover up the relationship between x and y. That's why it is called curvilinear non-linear. Okay. So further we have strong linear correlation. I already discussed with you. When most of the points lie close to the line or on the line. Weak relationship existence means when most of the points they are showing one direction, but they are not on the line exactly. Okay, so this is upward slope, upper positive slope. This is downward slope. Downward slope in negative relationship exists between x and y. Okay, this is upward and downward. Okay, now as already discussed with the linear correlation, no relationship. Okay, this is an example of linear or non-linear, and as well as no relationship exists. Now, if someone wants to calculate this value of R by hand or manually, so we have already covered the definition of covariance. We have already covered the definition of variance. So one just have to put the values in this formula and one can derive the value of R. And there is no any other case that you will have this value of R greater than 1 or less than -1. Okay, that means if you are getting something value of R greater than 1 or less than -1, that means you have error in your formula. So it must lies between -1 to 1. Okay, so this is the derivation that one can derive the that means value of R. Now, hello. Okay. So one thing more that, so we have just observed that the value of R is -1 to 1. Okay. But there is one more important thing that generally we use in statistics, that is we also test whether whatever the assumption that we have constructed regarding the regression coefficient, this correlation coefficient rho, okay, that is true or false. For example, I want to prove statistically that whether this correlation coefficient that is significant or not. Significance means whether the relationship between x and y, linear relationship between x and y exists from the statistical point of view or not. For that, we want the distribution of correlation coefficient. Okay, and in literature, there is a you can say result exists that the distribution is T that has n-2 degree of freedom. So why I'm discussing this? Although this thing is relevant when I will do the statistical analysis in Excel or R, I will show you one example for that. But before going to discuss this terminology standard error, I have to discuss with you the meaning of the standard error. Okay. So we want to cross check whether this relationship between x and y, the linear relationship between x and y exists statistically or not. Statistically significant relationship exists or not. For that, we will do the testing. And if the value of P, that means it is called P value, is coming to be less than 0.05. Okay, then we can say that the relationship between x and y are statistically significant. If someone is not able to understand this point, then I will show it, or I will discuss it again when we will do the coding in Excel or R. Okay. Now this table is very important for those who are not able to understand. Okay. So are the observation able to understand the relationship between independent or correlated observations? Okay. So as already discussed with you that we are doing the analysis for the continuous variable or quantitative variables, right? So when we want to test their mean, that means we have two variables and they have their mean themselves. We want to see whether the mean of these two groups are equal or not. We go with this test, and we will also use this t-test for the testing of coefficient of the parameter, coefficient of this regression variables. Okay, but my main emphasis is on linear regression. So here you can see that what is my requirement is that I need two variables. Okay, they are, one is independent, other one is dependent. Then only I can construct the relationship between them. So for that, we go with the simple regression that consists of one dependent variable and one independent variable. Okay, and for multiple regression, we have one dependent variable and more than one independent variable. I will come to that one also. But my main emphasis for today's session is that we have observed till now that whether there is any relationship exists between x variable and y variable, we have cross-checked through graphical manner, and after observing that they are related to each other, we derive the correlation coefficient. And after deriving the correlation coefficient, if it is coming to be close to +1, -1, or if it is positive or negative, we can say that there is some relationship exists between x and y. And after that, we will see whether one variable x can determine the value for y, or whether variable y can determine the value for x. So based upon that, we can say that x play as an independent variable if it is used for determining the value for y, or y is a dependent variable in that case. If y is the variable that is used to determine the value for x, then y play as an independent variable and x as a dependent variable. Okay. So now, so in correlation, the two variables are treated as equal. That is obvious. So in regression, one variable is considered as independent and another one is a dependent variable. Clear? So what is linear, as already discussed with you, that we have a straight line in which this B part, that is called intercept. Okay. And it remain constant. So you can see that the mathematical equation is y is equal to mx plus b, where b is a constant, m represent the slope. Okay, or you can say regression coefficient of x variable, and this coefficient m determine the relationship between y and x. Okay, for example, what is slope? So when slope means that if we are doing one increment in value of x, for example, if m is equal to 2, let us take one example. Okay, if m is equal to 2, then and b is equal to 1, for example. So what does it mean? So if I am changing the value of x by 1 unit, so automatically the value of y is changed by 2 units, because at least 2 units, because it is multiplied by 2. Okay. In the same manner, you can say that if the value of m is half, then you increase the value of x by 1 unit, then it will be, then y will be only be incremented by more than half only, because this multiplication impacts the relationship of x and y, or determine the relationship between x and y. And if we are able to find out this mathematical relationship in very accurate manner, then we just need the value of x that will help to determine the value of y. So we can say that our mathematical model is used for forecasting purpose or prediction purpose. Okay. So this is the regression equation. Let me tell you why we have written this equation in this manner. So in real life, what is going on, that we used to write down this equation as this manner, in this manner. Why so? The reason is because we have x variable, we have y variable. Okay, we have some constant also. This is called intercept, this is called slope or regression coefficient. Now the thing is, there are some chances that, or certain cases, whatever the mathematical equation you will use, you are not able to identify, or you are not able to get the exact value of y. So there must be some difference exist between them. So whatever the difference that is not observed by the model, that comes under the error term. Okay, so that's why we are more concerned about the assumptions of the model. Okay, then only we will test the assumptions of the model, then only we can say that this model is ready for the forecasting purpose. Okay, so now you can see here is, so we have assumed that alpha is our intercept, beta is our slope or regression coefficient, and we will use this model further for the forecasting purpose if the error term, whatever the assumption of this error term, that is satisfied with this model. Okay, so predictive value for an individual. So you can see here is yi is equal to alpha plus beta star x and random merit. So these are the fixed terms, because we have the values of x with us, we can determine the values of alpha and beta. So I will tell you that how one can determine the values of this alpha and beta, but this random term or error term, that is unknown to us, okay, in advance. So what we do is we first fit the model, and after we cross check this, the assumption of this model, and if the assumptions of this model is satisfied, we can say that this model is appropriate for the forecasting purpose. Otherwise, this model is not good enough. Okay, what are these assumptions? Linear regression assume that the relationship between x and y is linear, as already discussed. Then only we go with the linear regression model. Otherwise, we have to go with the non-linear regression model. This is the first assumption. The second is y is distributed normally at each value of x, right? That is again because we have assumption over error term alpha plus beta of x, and this is a constant term because we have the values of x and alpha beta, these are constant. So if we have some random variable epsilon here, so automatically y is again a random variable. Okay, so now, so if error has some assumption, that is automatically be applied over the variable y. Okay, the variance of y at every level of x is the same. So let me tell you this thing through graphical manner. So we are talking about this thing. So this sy upon x, that show the standard error, that is, and the relationship between standard error is that when you take the square root of variance, okay, and divided by the number of observation, that will become the standard error. Okay, so the assumption says that at each point of x we require a constant standard error. Okay, this is the requirement. Otherwise, if we have different you can say variance values, then we have a problem of heterogeneity. Okay, so we need such things that that error term, or you can say the variance of y at each values of x is same to satisfy this condition of homogeneity of variance. Otherwise, our model is not behave like a random pattern, or it means it's not good enough. Okay, so because we have some trend in our error term or some problem of heterogeneity in our error term, so we have to identify these things. And the next thing is that the observations are independent. So one has to consider these assumptions while applying linear regression model. And I will tell you that how one can test these assumptions also. Okay, the idea is clear, that corresponding to each point, we assume that the average variability around the regression line at given value of x, it is assumed to be equal at all values of x. Okay. So now let us discuss about regression picture. So we can say that this is our fitted model. Why I'm saying fitted model? Because y hat is a notation that is used to represent that equation that we have derived from the value that we have derived from the equation, that's a mathematical form. Okay, the true value of y is represented by y, and that fitted value is represented by y hat. Okay, and we will observe the difference between these two observations that shows the residual term. What is my residual term? For example, in my two data set, I have value of x as, so for example, 15, minus 15, or 10 was there. Okay, so now from this mathematical relationship, I got some value of y hat as minus, or you can say 8 plus 8 for this observation of x as 15 here. Okay, so now, so if I take a difference, so y minus y hat, so that is 10 minus 8, so that is my residual, the quantity 2. So why so? Because I can only construct a straight line here, so the actual value may not lie on the straight line. So there must be some deviation of this straight line from its value. Okay, so we will observe those differences through this residual term. Okay, so now you can also see that. So the straight line is given as in this manner. and there are two values of y, and we will see the difference of this y value from a straight line, and the value is represented as difference in terms of c and b, and the overall differences is given as a. So what these a and b, let me tell you. So what we do is we observe the variability, overall variability. Okay, we will observe the overall variability by this mathematical equation, and it is called that deviation of each value from its mean value, and it is called total sum of square, or called total variation. Okay, so now we have constructed a regression equation. Okay, this line. So if the deviation of this you can say line from its, you can say, mean value, and this is called sum of square due to regression, and if the difference of each point from its straight line, that is called sum of square due to residual. As already told you, that residual is the term that is used to show the difference of true value from its predicted value that we have derived from the model. So that is called residual. So this overall variability is split into sum of square due to regression plus sum of square due to residual. Hope this point is clear to you, or otherwise I will explain it again. Idea is clear? Hello?
Where with you, sir?
Can you hear me?
We can hear you.
Okay, so this thing is clear, or should I repeat again?
It's clear.
Okay, fine, thank you. So basically, let's take one example that is more helpful for your understanding. So I have one data set that consists of 100 observation. Okay, and here we can two variables regarding to this cognitive functioning of a brain. That means it is shown that there are two variables, vitamin D, and another variable that shows the cognitive function. Okay, that is measured through this DSST test. Okay, and the values are shown here as in terms of discrete manner. Okay, one is variable vitamin D, another one is values of DSST. Okay, so the requirement is that we need that our data set should follow normal distribution. So we can assume that if it is summing of bell-shaped curve. Okay, although it is not fully bell-shaped curve, but for understanding, for large data set, we assume that it is a bell-shaped curve, so we can go with this regression. Okay, and our main objective is to see that whether one variable vitamin D is helpful to determine the value of DSST or not. Okay, so first we have drawn the histogram for both the variables. Okay, I think the histogram concept is clear to all of you, or are you familiar with this or not? Just let me know.
We are familiar with it.
Okay, fine, thank you. And one has derived the mean and standard deviation. Okay, and mean shows the average value, and standard deviation shows the variability that we have in the data set. If the standard deviation is coming less, then we have less variability. If it is coming more, then we have higher variability. So we can say that these two from these two histograms, we can assume that both the variables for normal distribution. Now, so further what we have done, so we have considered four special cases in which we consider the first value of slope as 0, second value of slope as 0.5, third value of slope as 1, and the fourth one is 1.5. What does it mean? It means that in the first case, we are going to discuss further that considering m as 0 first, and assuming that no impact of vitamin D is coming to determine the value of DSST. Okay, in the second case, we consider m as 0.5. So whatever the value we have for x, so half of the value will be used for determining the value of DSST, and 1 means whatever the value of x we have, that determine same, that means that directly contribute towards determining the value of DSST. And if it is more than one, it means whatever the change we do in the value of X, that will impact more than that for determining the values of DSST, right? So as we have assumed M as 0 in the first data set in which we have considered M is equal to 0, right? So one can see that no relationship exists between vitamin D and DSST score. Okay. In the second case, when we consider M as 0.5, so the relationship is weak. How we can say the relationship is no relationship or relationship is weak? Because you can see that most of the points, they are not on the straight line, either on the positive side or negative side. They are scattered. Okay, and here you can see that the relationship is weak, but there must be some relationship because they are not as scattered like in the previous case. They are now arranged in a somewhat in a manner. Now, when we consider x is equal to, sorry, m is equal to 1, then we observe some more better relationship between them. Okay, and in the fourth case, when we consider this case of m is equal to 1.5, then we can say that there's a model relationship exists. Okay, and you can see that now most of the points are on the right hand side, so we can say that this is a positive side relationship exists between them. Okay, so how one can say that which one is the best fit line? So here you can see that while considering m is equal to 0, so we have only one straight line because we are only assuming 28 value as a constant value. And most of the points are not on this line, so we can say that relationship is very poor. That means there is no good model has constructed that cover up the variability that is present in the data set. And when we consider slope as 0.5, now we have some tilt in our equation. Now it is going on the positive side, so that means helpful for us to fit it in a better manner. And when we consider the case of m is equal to 1, then it is again slightly going towards a positive side. Okay, so when we consider m is equal to 1.5, then further we have very good relationship, okay, between these two variables. So now the next thing is that how we can determine these values of m or a, because we have considered this equation, either you have considered this equation alpha plus beta xi, or y is equal to mx plus c. Okay, c is a constant, mx is a slope. So alpha is a intercept and beta is a regression coefficient. For that, in our literature, we have some mathematical derivation that is used for determining these values of alpha and beta. Okay, so for the determination of beta hat, we first have to derive the covariance term, and in the numerator part, we have to take variance term and then take the proportion of them, and then you will get the value of beta. And for the determination of alpha hat, you first have to derive the value of beta hat, and then you have to put the value in this mathematical form, that is y bar, that is mean of y and mean of x bar. And after putting the value of beta hat, you will get the value of alpha. Then only you will get this forecasted value of y hat. Okay, after determining the value of alpha and beta, when you put it, then whatever the equation you will build, that is regression equation, and that is represented by y hat. Okay, so this relationship exists between beta hat, that is regression coefficient, and correlation coefficient, and this relationship is defined in this manner. And this SD is the notation that is used for standard deviation. So now what we have observed here is that if we consider m is equal to 1.5, okay, that means if we consider that from the data set we got m is equal to 1.5, then we are more able, that means we can see that the regression coefficient is coming as 0.49. That is good enough, but not very good. We can say highly recommended, because the relationship is there, positive relationship is there, but they are not highly linearly related, because most of the points are not on the line, they are far away. Okay, if all the points are on the line, then we can say that our mathematical model is very good enough for forecasting these values in the future also. Okay, so as already told you that our main objective is not to just construct a regression equation, that is why I had alpha plus beta x. We also have to observe whether this regression coefficient beta or alpha, okay, they are statistically significant or not. For that, we have to implement this test statistics. And these are the formulas. I'm not going to discuss what these formulas say, but our main thing is that we have to check whether they are statistically significant or not. If they are statistically significant, then only we can say our model is good enough for the forecasting purpose. And after fitting the model, okay, now the next thing is one has to cross-check the assumptions as well as. So I have discussed with you that what is residual analysis, silent I. That is yi minus y hat. That is the actual values of y minus the value that we got from the regression equation. So whatever the difference that will come, that is called residual. And we check these following assumptions: examines for linearity assumption, examine for constant variance for all levels of x, that is homoscedasticity. Then we also cross-check the normality assumption. Then we also cross-check the independence assumption. So how one can check those assumptions? So graphical analysis of residuals. Okay, first we plot it, then we will see. And how you will get the residual first? So see this. So we got this value for m is equal to 1.5 slope. So this is your intercept, this is your regression coefficient. And when we put the value of xi, let us suppose if it is 9.5 is the value of x, we got a forecasted value of y as 34. But the actual value is 48. So you can see that the residual is coming as 14. Are you able to see here? For m is equal to 1.5 and we have considered slope as 1.5. So we got the forecasted value as 34, but actual value is 48. So there must be some difference. So this difference is called residual, and we have noted down the difference, and this the value is coming as 14. So now, we noted down that these residual for all others observations also, and then we plot them. We plot them corresponding to our x-axis, and you can see that. So this is the model. This is the relationship between x and y, and we can see that most of the points are not on the straight line. Then we plot them. Then we plot their residuals also corresponding to x-axis, and if they are not randomly scattered, then it means that our model is not linear. Okay, and similarly from the residual we can see that if they are you can say plotted on x and y axis, residual is on the y axis and x value is on the x axis, and they are scattered enough, so we can say that model is linear. Okay, so in the same manner, the second assumption is residual analysis of homoscedasticity. So you can see here is when we are plotting the values of x and y. So if they are going to scatter either on the upper side, or you can say going upward or going downwards, so it means we have a problem of non-constant variance. So it means we have a problem of heteroscedasticity or non-homogeneity. Okay, and also the behavior of residual will be of such type. And when we have a constant variance, then it must be of such type plots. Okay, so now further assumption is residual analysis for independence. So we want that while plotting residual for the and on the y-axis and x-axis we have, they must be scattered. There must be no any increasing trend or decreasing trend, and there must be no any formation. So that shows that the residuals are not independent in these two scenarios, and they are independent when they behave in a random manner. Okay, so residual plots. So this is again residual plot, and we can't observe any pattern here. Okay, that's why we can say that they satisfy the assumption of normality. That means our error term for normal distribution, and there is no any you can say tendency of you can say heterogeneity present here. So we can say that what are the model that we have fitted till now that will work fine. So till now, if you have in doubt, you can ask me. And I also want to cover that how to fit linear regression model in Excel and R. But I think I don't have time today, but I will try to cover up all those things tomorrow. So till now, I'm not going to discuss whether I want to take your queries and try to resolve those things. You can ask me your questions if you have any. Hello? Can you hear me?
Yes, we can hear you, sir.
Okay. So, Dr. Meher, are you there?
Sir, I have a
Yes, yes.
question.
Yes, you can ask.
Yes, basically all we have been doing is the theoretical basis. Are we going to have a situation where we are going to make use of probably an example of a real life data to show all that you have
Yes, yes.
been teaching?
Tomorrow, I also plan to do the same analysis in Excel and R, but due to shortage of time, I'm not able to complete that. So I'm going to directly start with this analysis for the simple regression in Excel. Then we will go to R. Then we will try to cover multiple regression also. Is it fine?
Yeah, it's fine, sir. It's fine.
Okay. Any other query?
Dear participant, if you have any question, you can unmute your mic and put your query, please. The session is now open for discussion. All the participants are requested to put your questions, queries. If you have any doubt. Yeah,
Okay,
Tizani,
Charlie
you can
Adam.
open your mic.
Okay.
Tizani Adam.
Good morning, sir.
Good morning.
Good morning.
So I just want to emphasize on the material. Like, should we get the e-copies of the presented material, please?
Yes, yes, I will share. That's not an issue.
Okay, at the end of the session, we can get it all after the workshop proper.
Sorry?
I mean, can we get the presentations, please?
Yes, I am going to share the slides. Do not worry about that.
Okay. Thank you very much. That's
Okay.
it. Thank you.
Any other question from the audience?
Participant, please don't hesitate. You can unmute your mic, or either you can put your questions in the chat box also. You can put in the chat box.
The main objective of today's session is that you must know that where you have to use these tools. Right? That's why I've spent time on this discussion.
Hello, I come back again.
Yes.
No, I'm not talking to you. I'm just trying to say that today's session is basically designed that you must know that where you can use these tools. Okay. Sometimes we do not know that for which data set these tools are relevant for. So that's why I have discussed upon that types of data. Then I have discussed thoroughly that where you have to use these tools.
Okay, for example, in Nigeria, we mostly use that eViews. Can we get the same outputs by we using eViews? Or?
Actually, the thing is, eViews is a paid software, right? And I do not have access to that. So I will go with this excellent, you can say R software, because both of them are, we have a license of Excel and I have and R is a free version software.
Okay, I mean, can the output be the same?
So basically, if you want to, if you have the theory is clear in your mind, you can go to any eView, you can say video, then you can implement that. That's a different thing.
Okay, thank you, sir.
Okay.
Any more question, please? Tizani, again, raise the hand. I think, sir, there is no more question.
Okay, sir. Thank you.
Yeah. Thank you, dear professor, for a nice presentation. And tomorrow we will continue the same discussion. And Dr. Mr. Kapoor will be with us tomorrow also. There are 2 consecutive sessions for this statistical analysis. And also some of the participants are asking other softwares. Since R is open source software, Python is also there, free available. We can easily use these softwares in our findings to visualize the result for statistical implementation. So we are using R and Python. So this workshop will be go through by using R software because it is free available and anyone from any place can easily access and download, install in your system, and everyone can use this software. So the main purpose is Dr. Kapoor saying that which tools are you can use and what are the purpose to use these type of formulas in social science and humanities. So first thing is to familiar the formulas and why these formulas are required for statistical analysis. This is very important. And then after how we can use softwares. So R is a very friendly software. Just you need to use and start to work on it. But the most important thing is the basic concept must be very clear as Dr. Kapoor explained all the things which are required for findings for research, mainly in social science and humanities. And I hope that the content which presented in this session are very useful to all the participants. And the feedback form and assignment for the yesterday and for today's session, both will be shared in the WhatsApp group after this session. And I request to all the participants, please submit your feedback always regularly, as well as assignment which we share with you. So thank you for today's session to join this faculty development program. And tomorrow we will join the session at the same time. Thank you to all to show your interest in this ongoing faculty development program. Thank you to all.
Okay,
Thank you, Dr. Kapoor, sir. Thank you.
sir. Thank you.
Thank you.
Now we can leave the meeting and I request to the Prem to end this session.